these are problems you've seen before, so take a moment to read that to yourself, and then tell somebody next to you which strategy you think would be best to solve this problem. The unit is ratios, rates, and percents, and the focus is on how ratios relate to real-world situations and strategies that you can use to solve ratio and rate problems. I overheard table, I heard double line graph. Are both correct? Yeah. You can use more than one strategy to solve these problems. Today in class, I showed them samples of student work that they had completed in previous classes that demonstrate the use of those practices. Okay, so this person used a double number line, and what they're doing is showing that you need 3 parts nuts for 2 parts basil, and then they're going all the way up to 15 to get the answer 10. Raise your hand if you'd like to tell me what you think this one would involve. What strategy? Charlie?
A tape diagram.
Why do you think that would be a good strategy?
Because it shows percents and percents out of 100, and a tape diagram shows percents out of 100.
You're right. Here we have a tape diagram, and as Charlie said, all of the sections need to add up to one whole, which is 100%. The standards are focusing on ratio, rates, and proportion, and I was also emphasizing 2 of the mathematical practices, modeling of mathematics and attend to precision. Today we reviewed what the mathematical practices were. So by explaining your thinking, sometimes you're better able to understand it, and I think that's what precision's really all about. And when you were working on the top-down web, I came in and listened to your discussions, and I took little sound clips, so I'm just going to play one of the shorter sound clips. This was Jeffrey and Tyler.
There are 2 types of ratios, which one of them is part to whole, which is how many of one object in a group out of the whole group.
And a part-to-part ratio is comparing the amount of one object to another object.
Okay, so that was an example of using precision in your language. And finally, they were given a set of problems to solve individually, and they worked those out in class yesterday. So the problem set that they solved individually then transferred into the work we did today. So everybody can join their groups and go ahead and get started. Students were placed into groups, and each group had to sit in a circle to discuss the solution to the problem set that they worked on yesterday.
Let's start out with our answers for number 1. For the 40 inches, we have 4 feet.
48.
Yeah. For 60 inches, we have 5 feet.
Yep. I got 84 inches.
Me too. 84. Yep. Okay, so what did you guys use to figure that out?
I used a double number line.
Me too.
So you'll be making a display for problem 3. And then they became an expert on one of the problems within the set. You're just going to randomly pick a number. So you'll be creating a display all about question number 4.
I think we should do the table. It's the easiest to understand.
They combined their ideas to create a visual display that demonstrated how they solved the problem.
All right, double line graph. It could hold 4 students for 1 car. There'd be 1 van, and then there'd be 6 students inside 1 van.
Our answer is 6
minivans, 1 car. Yes. All the cars combined can hold 40 kids, and there's 39 kids they need to be taken to the green tree.
I always explain to students that getting the answer is only part of what they need to do, that it's more important to be able to communicate your thinking. And I think that's where the exciting part of mathematics comes in, seeing the different ways you can approach a problem and learning from one another and being able to share your reaction to that.
We could always use a double number line.
That's true.
Yeah.
So on top of the first box, do 10%, and below it, do 3.
I think precision means a lot of things. It could be getting the correct answer, labeling your answer correctly.
Well, how about we write the ratios right over here?
Yeah.
And being able to talk about your answer and how you arrived at your answer. It's about using appropriate terminology for the particular grade level and being specific with the information.
Now with the ruler, the increments, they need to be equal.
Good word choice. Can you explain what you mean by increments?
The evenly spaced markings on the double line graph.
Oh, perfect. Very good. Hey, you are doing a great job so far. I see a variety of strategies being used. I just paused the timer, but take a look. We're at about the 10-minute mark here. So you're going to need to make sure you save time to prepare your presentation. They prepared a short presentation to their classmates explaining the strategies that were used. And just a few things to keep in mind. Make sure everybody's included and that when you're presenting, the other people in your group are not blocking the work. We want to make sure we can see everything at all times. So you might have kids sitting down and then standing up when it's their turn to present, but have it all worked out.
Then we'll make one more demonstration and then we'll practice to present.
Yes.
Wait, so Nick, how about Nick reads the part A for that, and then someone else reads part B?
Yeah.
The number double line graph? Yeah.
Last 5 minutes to pull this together. You're doing great. We are at the end of this unit, and today's work was sort of the culmination of the unit.
For part B, our group used a double number line to show our work, and we labeled them with I for inches and F for feet.
So it's 7 feet is equal to 84 inches.
We did question 2, and it is called the Green Team Field Trip.
So for this problem, we used a table. One car can hold 4 students, so the ratio of that is 1 to 4.
And if you have 7 minivans that can hold 42 students, and the ratio to that is 7 to 42.
There's also more of an emphasis on those mathematical practices and the habits of mind, which was a focus of today's lesson.
Well, we solved this problem in multiple different ways. And one way we did was in a graph. So if you have 6 quarts red and 9 quarts blue, you have 15 quarts total.
By implementing those practices, students are understanding how to be a mathematician and communicate their ideas.
2 times 3 equals 6, so it works for all of them.